Hi guys. So what I want to do over the next few weeks, not including spring break, I want to actually start talking about some of the review things, some of the things we've done throughout the year. I know some of you have taken the SBAC, some of you will be taking the SBAC. And so I want to just kind of bring back some of these things for you to practice. You can pause these videos at any time and just and try the problems and check to see if you got them right. So this first one, I want to talk about terminating and repeating decimals. And I want you to also, we're just going to sneak in there that all fractions are rational numbers. If it can be represented as a fraction, it's rational. So if we convert these to decimals, if I'm right over here, 3/8, remember this is just a division problem, okay? So I could do it longhand. I could go 3 divided by 8, knowing that 3 doesn't go into 8, it's going to be a number less than 1. So I'm going to put my 0 over here. And 8 goes into 30. 8 goes into 30 3 times. And bring my decimal up. 3 times 8 is 24. I just do my math. Subtract that, I get 6. I can put another 0. It's 60. I know 8 goes into 67 times. 7 times 8 is 56. Now I have a 4 left over when I subtract it. I got a 0. 8 goes into 45 times exactly, and I don't have any remainders, nothing's left, so I stop. So that becomes 0.375. That is what we call a terminating decimal. Okay, it stops. Now, repeating decimal, you can try this next one, 2 divided by 9. Try it, because I'm going to give you the answer right now. 2 divided by 9 equals 0.22 forever. It keeps going, but we write that like this, 0.2 with a line over it. It's repeating the same 2. We're going to use that bar notation to note that. Okay, now try 1/5. 1 divided by 1/5. 1 divided by 5. So I get 0.2, and that becomes a terminating decimal. It stops. Okay, example of a irrational number. It's one that goes on forever and ever. One of them, the most famous irrational number, is pi. There's no pattern to it. It just kind of keeps going. And then other irrational numbers you'll usually come across is things like the square root of 2 is irrational because it's not perfect. A rational number is the square root of 25 because that equals 5. The square root of 2, it's something that goes on forever. There's no pattern. So let me just remind myself of what that is. It's 1.4142, keeps going, okay? But there's no pattern to it. But you'll find out if you ever want to challenge this, pick any fraction. It'll either repeat or it'll terminate. If you don't see the repetition or what the pattern is, keep going, you'll find it. Okay, even the sevenths, like 1/7 repeats. Not in your calculator, you got to do it by hand, you got to go out a little bit further. Okay, so I want to go over some integer stuff. And so I want to talk about these rules, multiplying integers, when it's going to be positive, when it's going to be negative. So for example, when there is a negative and a positive, your answer is going to be negative. If they're not the same sign, it's going to be a negative number. So 3 times 5 is 15, and since only one of them is negative, my answer is negative. So we just do the math as usual. 4 times 6 is 24. Since they're both negative, my answer is actually going to be positive. See that they're both negative? So this last one, I threw a fraction in there. Remember that we can just put a line and a 1 under there. And we just multiply straight across. 1 times 3 as well. It's kind of not straight because that 3 is down there. 1 times 3 is 3. 5 times 1 is 5. And now because only one of the numbers was negative, the answer is negative. So understanding this is going really fast and there's not a lot of problems to review, you can actually seek out more problems, or you can contact me if you want some more practice problems on some of these. Okay? Dividing and division is the same rules as multiplication except you're dividing. So if I divide 4 into 112, I get 28. But because one of my numbers is negative and one's positive, my answer is going to be negative. Now both of these next two are negative, so my answer is going to be positive. So I just need to figure out what 72 divided by 6 is, and I get 12. And since they're both negative, my answer actually becomes positive. So now this last one, I threw this at you, negative 2 and 3/5 divided by 3. So let's just do the math problem first. 2 and 3/5 divided by 3. Okay? So first I'm going to convert this into a improper fraction. Multiply here, add here. 5 times 2 is 10 plus 3 is 13. 13/5 divided by 3 is the same thing as 13/5 times the reciprocal of 3, which is 1/3. Okay, so I'm going to multiply 13 15ths because I just multiplied here. So my answer is 13/15ths, but my answer is going to be a negative 13/15ths because only one of them was negative. All right, so this is definitely one you're probably going to end up wanting to practice. I got some rules up here. I know it becomes kind of blurry and it's kind of tiny on this one. But when you have the integers with the same sign, all you do is add the integers and then keep the sign. So like this second one right here. Okay, so we have 15 plus 7 is 22. And since they're both negative, it's going to be negative 22. Okay, find the other one that has both the same sign. I didn't do any positive and positive because I figured you guys know just to keep that a positive. So this one right here. So I do 52 plus 9, 61, and they're both negative, so it becomes negative 61. So it's a little trickier, and I'll go work on the side over here, when they have different signs. You're actually going to subtract them. So I got a 12 and an 8. One's positive. I'll write that. You don't usually write positive 8. One's positive, one's negative. So I'm going to go 12 minus 8. And we can bring in absolute value rules and all of that. 12 minus 8 is 4. So my answer is 4, and it's a positive before because the 12 was bigger and it was positive. Okay? So same thing on the third one. Different sign, so I'm going to subtract. 22 minus 9. Well, that's 13. So my answer is 13, but because the 22 is bigger and it's negative, my answer is negative 13. Think of it as if I owed my sister money. I owed her $22. I gave her 9. I still owe her money, but I owe her less money, negative 13. I owe her $13 now. Okay, so this is the one that's probably the most confusing of them. I have all kinds of stuff on the side. I have how to subtract, you add the opposite, and then I brought back in the adding the integers. I'm not going to use one of these as an example. I'm going to use one that we kind of know first, and we'll work from there. Like if I said, what's 7 minus 5? Most of you would say it's 2. Okay? But I can also say that's the same thing as 7 plus negative 5. Okay, because we know I subtract them. 7 minus 5 is 2. The bigger number is positive, so it's a positive 2. That seems like a lot of extra work for when I'm just going 7 minus 5. But what I want you to see is we can actually, you're going to add the opposite. You're actually going to change the sign of the second one. So let's start with this first problem. 14, I'm going to change it to addition, and it was a negative 18. Now it's going to be a positive 18. So now I just have 18 plus 14. So 18 plus 14 is, I believe, 32. Okay, and pause at any point that you'd like. Okay, because what's happening is I'm having 14 and I'm taking away 18 negatives. There are no negatives in 14, so I'm actually going to be adding 18. Kind of another weird way to talk about that. Okay, I'm actually going to clear that so we have some space. So 13 minus negative 9. So I'm going to change it to an addition, and this number is going to become positive 9. So now we have different signs. So I'm going to go over here. I'm going to subtract 13 minus 9 because they're different signs. That's 4. My answer is 4. But because 13 is bigger than 9, or the absolute value is bigger, it's going to be negative 4. Okay? So let's try this one. So negative 42, and now I just have one sign here, so it's plus, okay, negative 19. I'm going to change that 19. I was subtracting a positive 19. Now I'm going to add a negative 19. Same sign, so I'm just going to add them up. 42 plus 19. Well, that's 11. I carry that over at 61. And my answer, since they're both negative, negative here, negative 61. Okay, last one I want to try. Then you can find all kinds of problems on your own, or you can let me know if you need some practice. So I'm going to change it to an addition problem, and then I'm going to change the negative number to positive. So now they're different signs, a negative 52 and a positive 9. So let's go 52 minus 9. I got to borrow. This is 43. My answer is 43, but because the 52 is a bigger absolute value, negative 43. So these are just some things to practice. This is what we're going to focus on this week. I'll add new things next week. You can find your own stuff to practice or work on. You can go back through this and watch this, or you can also get a hold of me and I can come up with some practice problems for you. All right, thanks guys.